Hi everyone, welcome back. Today we will see a problem longest subarray with sum k, and I am Shreyans Jain. So this is the problem statement. We are given an array of size n and an integer k, and we need to return the size of the longest subarray which sums to k, and this is a part of our algorithm animation playlist. Please check, the link is in the description. So I recommend you watching the previous video I have made on subarray with sum is equals to k, because we are gonna use the same approach here. So it will be helpful for you to understand it more clearly if you have watched that video. I have attached the link in the description and in the I button in the top right corner. So let's take this as an example. We are given this array and we need to find the subarray with sum equals to 8. So this is the subarray with sum is equals to 8, and I already told you about S1 and S2 in the previous video. This is the required and this is S1. S1 is the subarray starting from the first element to the element at the last position of the required, and S2 is the subarray starting from the first element to end at one element before the required element. Here we know S1 minus S2 is required, and if I change the equation little bit, we get S1 minus required is equals to S2. What it tells us is I have S1. If I subtract S2 from it, I got the required. So we will use the similar logic to find the length of the required subarray. If I know this length and I subtract this length, I got this length, right? So these are two pointers. This is pointer for S1 and this is the pointer for S2. So if I subtract from this pointer to this pointer, I get this required length. Let's take one more example. So here also we need to find the maximum subarray which have sum equals to 8. So here also S1 minus required is equals to S2, and if I take S1 from 2 to 4, then the S2 will be 11, which is the sum from 2 to 4, and minus 8, this is the sum, is equals to 3. So this is our S1, and I have two options for S2 here, because this is also S2 sum 3 and this is also S2 sum is equals to 3. Now if I take this as S2, we get this as the required subarray, and if I take this as S2, then this is the required subarray. It's good for us if we take this as a S2 because then we get a maximum length. So what we observe from here is it's good for us to store the lowest index for a given sum. Here for sum is equals to 3, either I can store 2 or either I can store 4, but storing 2 is good because then we get largest subarray with given sum. So let's see the algorithm. Algorithm is kind of same as the subarray sum k. We will store the sum so far. We will check if sum minus required exists, and then we will update the max length if we get a length which is greater, and then also we store the current sum so far in the index so that we can use it later. So here we have the function length and ARR array, the size of the array, and a sum to which we need to find the length. So we make a map. Here the map stores if we have a previously sum and at which index we have that sum. So sum here stores the current sum so far, and max length is the length of the longest subarray. So we here iterate from first element to the last element. We add up the elements one by one. If the sum is k, it means the subarray is formed from 0 to ith index. That means max length is I plus 1. And then we check if sum minus k exists. If yes, then we update our max length. We take the max of both. So if the sum doesn't exist in our map, we store it, and then at last we return the max. Thanks for watching. Hope you will like it. Don't forget to hit like and subscribe to view more content like this.